Welcome back. So in this section, we're moving on to an entirely new concept. Now, instead of dealing with radicals, now we're going to be exploring their connection with rational exponents. Now, the connection as rational exponents can be written as radicals. So something that is to the 1/2 power is the same thing as a square root. Something to the 1/3 power is the same thing as a cube root. Something to the 4th power or to the 1/4 power is the same as a 4th root. So there is a direct link with rational exponents, with fractional exponents, and radicals. So let's investigate this relationship. So 216 to the 1/3 power. That is going to be the same thing as the cube root of 216. Now, once we think of it as a cube root, now I can look at my powers chart. Cube root 216, that's going to be the number 6. 1/2 power, well, that is the same thing as a square root. Okay, so square root of 7 times square root of 7 would be the square root of 49, or just the number 7. So we need to make sure we understand that link, understand that connection, that a rational exponent, its denominator is a root. Okay, that's going to be essential in this next section. Now, can we go the reverse? And the answer is yes. If I give you a radical, the square root of x would simply be x to the 1/2 power. The 5th root of 7 would just be 7 to the 1/5 power. Okay, so those are things that are really important to understand, being able to go back and forth from a fractional exponent to the radical, or from the radical to the rational exponent. All right, now, there is a more generic rule, okay? So the generic rule is when you're dealing with a rational exponent. Like we said, its bottom is the root. The numerator, the top of the fraction, is actually the power. It's the exponent of whatever is there. Now, just me telling that to you probably doesn't make much sense. I think it's going to make a lot more sense once I dive into some examples of what that looks like. So let's take a look at these. So the top, remember, is always the power, like solar power, the sun. The bottom, think of the roots of a tree. The bottom is going to be the root. So let's apply that. So for these, remember the root is the bottom. So this is going to be a 7th root, and then the top is the power. So the 7th root of x cubed. This one, the bottom is the root, the top is the exponent. So this is the 5th root of y squared. Now this one, if it's written as a decimal, we need it as a fraction. So this 2.5 is 5/2. So you're going to want to rewrite the decimal as a fraction, and now we can apply that process. So this is going to be a square root, because the bottom is the root, and then the top is the exponent. So the square root of z to the 5th. Now my challenge for you is this one can actually keep simplifying, right? If we have a square root, well, this can actually keep going, can it? Using the skills we got in the first half of the chapter, 2 goes into 5 twice, then there'll be one of them left over. So we do want to retain those skills we used in the first section, but of course the emphasis would be on those first two examples. This one is kind of more of an extension, just something to continue exploring the skills we gained in the first place, back in that first section. Now, of course, if we can go one direction, we want to be able to go the other direction too. Okay, so let's go backwards. So here, my exponent is 5, and my root is 2. Okay, so that's going to be a to the 5 halves. Here, my exponent is 3, and my root is 5. Now these ones you're going to write separately, because here the 5 is an exponent of 1. So exponent of 1, root of 2. The c has an exponent of 9 and a root of 2. So sometimes you are going to have to write them separately like that if you have multiple things in the same radical. Okay, but you always put the exponent on top, root on the bottom. Okay, that's always the mentality I want you to have. That's always the way I want you to think of this. Now this one. This is a fun little example because 25 is actually 5 squared. So if I transform it in my mind and I think, hey, I know 25 is 5 squared, now I can write it like this. Exponent on top, root on the bottom. So instead of 25 to the 1/3, I can write it as 5 to the 2/3. Okay, so again, just a fun little extension for you to consider when you're looking at these types of problems. All right, before we move on to our next idea, let's take a look at a word problem. Kepler's third law of orbital motion shows how you can approximate the period p in Earth years it takes for a planet to complete one orbit around the sun. Use the function p equals d to the 3 halves, where d is the distance from the planet to the sun in astronomical units. How many Earth years does it take Mars to orbit around the sun? So its period is that distance in in astronomical units. It's 1.52 to the 3 halves power. Okay. Now, remember on the calculator, that's going to take the caret button. So we are going to type in the calculator to evaluate this is 1.25 to the 3 halves power. Okay, that's kind of how you're going to have to type it in this instance because it's not a nice exponent. So 1.25 to the 3 halves. So it takes Mars about 1.87 Earth years to travel around the sun. So when we're talking about physics examples, science examples, a lot of them end up having rational exponents. So this concept becomes very important for the sciences to understand how they work. Now, we can use this concept to actually simplify numbers. So when we have a number to a rational exponent, we can actually simplify them using these methods. Okay? So what I always want you to consider is that the denominator is the root and the top is the exponent. All right? So again, when you're doing this on your own and you need to recall this process, that is what this process is. Otherwise, for now, you can just step through the process with me and then reflect on the actual words later. So I want you to consider this. The bottom is the root. So you have the square root of 9, and then the top is your exponent. So the square root of 9. Well, the square root of 9 is 3. 3 cubed is 27. So 9 to the 3 halves power just is 27. So that's what you need to be able to do with these, is first take the root using the bottom, and then the top is an exponent. So here we have the cubed root of 125, the bottom is the root, the top is the exponent. The cube root of 125 is 5. 5 squared is 25. So 125 to the 2/3 power is 25. Now remember, here, bottom is the root, so the 5th root of negative 32, the top is the exponent. Now maybe you forgot the 5th root of 32. Well, don't forget we have our handy dandy power chart in case you forget these things. 5th root of 32 is going to be just 2. With an odd root, remember a negative is okay. So the 5th root of negative 32 is negative 2. Now take that to the 4th power. Negative 2 to the 4th power is going to be positive 16. Remember, adding negative to an even exponent is positive, so 2 to the 4 is 16. Now, the one little trick in here, what if my exponent is negative? So here I have a negative exponent. Well, remember, that will send it to the denominator, so it can become a positive exponent. So make sure you're still aware of that. A negative exponent, just send it to the denominator, and then you'll be able to keep working. Now, it still works exactly the same way. That 2 is my root, so a square root. The top is my exponent. Square root of 16 is 4. 4 to the 5th power. That's something even I'm going to need my calculator for because I'm not used to thinking of exponent that high. So 4 to the 5th power is going to be 1 over 1024. And that's going to be my final answer. So not too difficult. You just have to make sure you're aware. Think bottom is a root, top is an exponent. If you happen to have a negative exponent, well, then you just have to make sure you send it to the denominator. You send it down, and then the top becomes a 1. So that's going to be all for our notes today. Thank you so much for joining me. Make sure you take a moment and write that summary for me, making either any connections or anything, any questions you still have for me, and then come back ready to do your practice work.